And so, that might seem a little bit funny that I'm hosting this lunch and learn with a California river steward. But part of that is because I'm helping lead our hot home waters team. And Andy is one of our members of that hot home waters kind of climate change initiative team. So we're actually going to be having our first meeting on July 26th at 4 p.m. If any of you on this call are also interested in joining that group, if you're concerned about climate change in your basins, we'd love to have you help us out. I'd like to start out just with a couple little housekeeping things. I set it up so that as people enter, they're automatically muted, but if you've unmuted yourself to chat a little bit, that's fine. But if you want to go ahead and mute yourself before we get started, just to make sure that there aren't any interruptions of Andy and Bill, that would be great. And go ahead, if you have questions during the meeting, go ahead and drop those in the chat. If you look down at the bottom of the screen, there's a little chat function, put them there, and Jennifer is going to be monitoring those and I'll be monitoring those. So we'll make sure that those questions get asked after the presentation. So with that, I'd like to introduce River Steward Andy Marx. He's been a river steward on the Shasta for about a year and a half, since December of 2020. He's also with the Friends of Shasta River since November of 2020. So he's really deeply immersed and very knowledgeable about the Shasta River. And we're really lucky to be joined by Bill Chesney, who is a retired fisheries biologist with California Department of Fish and Wildlife, where he was a biologist for 25 years. So with that, I'll go ahead and mute myself and hand it over to Andy and Bill.
Okay, great. So hi, everybody. I'm Andy, and you'll get to hear from Bill in a second. He's got essentially the biology pretty well ingrained in his expert brain, and I rely on him for all that. So as far as the Shasta River is concerned and how I got involved with the Shasta River, for 25 years, I worked in Wairika, which is the Shasta River flows basically through Wairika, or right next to it. And I'm a avid steelhead fisherman. I don't know if avid is better than obsessed, but that's what I do and did for essentially ever since I moved to Siskiyou County and started working in Wairika. And so several times a week during the fall season, I would spend time around various spots swinging flies on the Klamath. That journey got me essentially tromping through the Shasta River on a pretty regular basis. And other than maybe Fish and Wildlife employees, I'd like to think I probably have stepped in that river more than the majority of people. And through that process, I kind of saw it in all its kind of shades of health. In 2018, there's a spot I go to where I have to go through the Shasta and cut out a trail. So I go early season, and going in there early season, the river was just exceptionally low. And I had seen it low before, but this was the worst I had ever seen it. And when I went and checked the gauge, you kind of get married to these gauges, but the gauge was at 8 CFS, which is, confirmed what I saw, which was, it was basically like ankle lapping water, not like mid calf deep. It was just alarming, and it didn't seem right. Both because it was so low, but because it just, when it gets that low, it also gets kind of a bad odor to it. It's an agriculturally impacted. And so anyway, that was one kind of thing that got me alarmed. And then I had a couple of conversations, just, there's a big outdoor community here in Mount Shasta. And one of those involved some kayakers who told me how they had paddled the river at one point and vowed to never do it again. It was one of the most offensive experiences they had ever had in paddling in terms of the water quality. I mean, there was plenty of water to boat, but didn't seem right. So anyway, all those things kind of weighed in, and I started making phone calls. I talked to some folks involved in Klamath water issues, and that path eventually led me back to Bill Chesney and another guy named Dave Webb. Bill's the biologist and knows what goes on with the fish. Dave is a resource specialist in the Shasta Valley, and he knows how the place is plumbed better than anybody in the Shasta Valley. So we sat down and had kind of a lunch meeting in a park in Wairika, and they told me all the stuff about the Shasta River that I was like, I mean, a lot of the terms I didn't even understand. 303D impaired and Clean Water Act and CISA and ESA and all the stuff. That kind of got me on another bit of a path of researching the Shasta River. And I really came up with a lot of studies and plans to fix the Shasta River. I learned what impaired under the Clean Water Act meant in terms of the Shasta River, that temperature and dissolved oxygen were major problems for the river, and fish need that to survive. Salmon need that plus cold water to survive. One of the things I came across was a recovery plan that was drafted in 2003. And then I came across the fish numbers and the coho numbers, which were not getting better. They were getting worse. And it really just all kind of came together that something needed to happen. There needed to be more advocacy. During our conversations, Bill Chesney often said, we need to start a Friends of the River group. And to me, I don't know, Friends of the River sounded a little bit like too soft, perhaps, but it's really come to be, it is what you put into it. And our goal is to improve the quantity and quality of water in the Shasta River. And our tactics are to engage everybody and be aggressive. There's been too much collaboration on the Shasta that depends on the voluntary kind of goodwill of the landowners and the diverters. And that hasn't worked. It hasn't resulted in more water in the ditch. What I learned was that the coho in the Shasta River, they're kind of, Bill said this the other day when we were talking about this presentation, they're the canary in the coal mine. If coho aren't doing well, it's kind of a domino effect. The steelhead are probably next. The interesting thing about the Shasta River is it only amounts to about 1% of the total Klamath River flow. In good years, it can add or harbor, produce, whatever you want to say, 50% of the fall Chinook run. And that sounds like a great number, so the river must be doing good, right? Well, it turns out the fall Chinook, they come into the river as the flows drop, or excuse me, as the irrigation season is stopping, so the flows then increase. So they kind of have this good timing when they arrive, and then the fall Chinook babies, they don't have to stay in the river for a full summer season. They leave just as irrigation season begins. The ones that don't get out when irrigation season starts probably don't make it, but a lot of them do. And that's why it's so productive for fall Chinook. Unfortunately for the coho and the steelhead, coho especially, have to over summer in the river, and that's when things get sticky for them. The beauty of the Shasta is that it is a resilient stream in that it is sourced mostly, its main base flow is springs that are sourced from glaciers on Mount Shasta. So rather than being dependent on snow melt entirely, many streams decline in June, July, and by now, you got a lot of dry snowmelt creeks. There's one snowmelt creek on the Shasta Parks Creek that's dry right now, but there's these base springs that it's super nutrient rich, cold, salmon sustaining water. And that's what makes it drought resistant and resilient, and such an awesome resource that if we restore it, it's going to really supercharge these fish runs, the coho and the steelhead. And then there's another kind of subvariant of the Chinooks that's pretty amazing that could also do well if the springs were restored. The springs are spoken for. They're part of an agricultural diversion system that involves dams that pond the springs, warm the water is diverted into ditches that go through multiple pastures. So by the time they reach the river, it's not good water. It's essentially kind of a hot sewage water situation. So you can look at the river at the upper end and you got like 150 CFS of, potential good water. By the time you get to the mouth, this summer we had 2 events where the river got down to 3 cubic feet per second at the lower end, which is not enough for fish. So anyway, that's kind of the background. We think that we can, through advocacy, get these springs back in shape. And I'm going to turn it over to Bill to talk some about that, how the springs play an important role, and snowmelt as well, which is also impounded. That's part of the story. But anyway, I'm going to turn it over to Bill and let him tell you about the kind of biology of the river.
Okay, hi everybody. I'm going to grab the screen here and put this stuff on there. There. Everybody see that?
Yep.
Yeah, good. So like Andy says, we're going to talk about some work that the Department of Fish and Wildlife started back in 2004, I think, is when we started trying to figure out where coho were over summering on the Shasta River, because you couldn't find them if you went out looking for them. And yet in the fall of the year, the adults came back, and in the spring of the year, the rotary trap would catch juveniles as they were leaving. So this is shot upstream of one of the springs where some of the prime rearing habitat in the upper watershed. See if we can go here. So what we know about coho in the Shasta River is learned from these projects, the Department of Fish and Wildlife projects, including an adult counting where that's operated in some form or another since 1930. We've got a rotary juvenile traps that began in 2000, radio tagging of adults that were migrating upstream, and pit tagging of juveniles that started, I think, in 2005, maybe 2007, and then watershed-wide temperature monitoring, which has been ongoing long enough that we got a pretty good handle on what's going on with the river. That's a big chunk of change to operate all those projects for all those years. We owe a lot to Bureau of Reclamation in Klamath Falls, Shasta Valley RCD, Pacific States Marine Fisheries Commission, and a number of private donors that stepped forward to keep us operating in tough years. So this is a review for most everybody, but I just want to make sure that you guys are aware that coho have a life history that pretty well is, it's a 3-year life history, 18 months in freshwater and then 18 months in ocean. And that's pretty fixed compared to like Chinook salmon, which can come back from the ocean anywhere at age 2 to age 5. Coho almost always come back at age 3. There's jacks, there's 2-year-olds that do come back. But what that allows us to do is to follow the cohorts. You can, each cohort that comes back is pretty much all from the same year, each group of fish that comes back in the fall. So looking down at this chart down here, we're actually looking at, this is a generalized life history for salmonids. But when they get into this par stage, that lasts for an entire 12 months. So they're coming back and spawning March through November through January, fry emerging in March, April, and then they're going to stay in the river for an entire summer and then leave the following spring as smolts. So that makes them really vulnerable to everything that's going on in the watershed, which is why they're listed as a threatened species, because it's a life history that really collides with agricultural and domestic use of water. You know, there's no, where unlike the Chinook, like Andy was saying, the life history of Chinook that does well in the Shasta River with this water regime is they leave in April. They leave up out of the gravel in January and they're leaving by April, whereas coho and steelhead have to suffer through an entire year. So going back to those cohorts, if we look at this is returning in by groups of fish that would come back every 3 years, you can see that the fish in 2001, we had 291 adults. And then when that group came back in 2004, it actually increased. And then from that point forward, every 3 years, it's shown a decline, with some exceptions where it's coming back up a little bit. This is the cohort number B, or letter B. It never was very strong, and it's even weaker now. So when we started counting in 2002, it was 886. Now we're presently looking at like 37 adults coming back in the fall. This is the same thing for the third cohort, but they've all pretty well bottomed out. They're all down here below 50 adults. And the problem with 50 adults is you're not going to produce enough juveniles that are going to be able to, properly reproduce that cohort. You're kind of like in the cellar. This is what that looks like. Shoot, that's not supposed to be there. Sorry. This is, looking over on the left, these are the brood years. And if you look at 2012, we had 115 adults come back. 991 smolts were produced from those fish, and we produced 9 smolts per returning adult. And then just a few years later, you had 52 adults come back, but they produced 81 smolts per returning adult. So the question is, why are some broods producing, way more? So if you can produce 4,000 smolts, you can reproduce the cohort. You can actually climb out of the hole. But this variability between like 9 smolts produced for a returning adult versus 81 is kind of at the heart of the problem. I'm going to go to this. So what causes a very number of smolts produced per adult? It's a depensation, where you've got a small number of adults coming back over like a 6 month, or a 6 week or an 8 week period. They literally can't find each other. And what happens then is you end up with males not being able to find females throughout the watershed. And as a result, you've got poor spawning success. You've got environmental conditions, and then you've got a series of things that can cause the low survival. What we found from working with Coho is that there's 3 ranges of temperature that we're going to classify as optimal, optimal, which is 10 to 15 degrees centigrade. And at those temperatures, all these 4 different things tend to be optimized. You get the best growth rates, swimming performance is optimized, disease resistance is optimized, and the pathogens have reduced virulence. So it's kind of like everything's working in the favor of Coho in that temperature range. Between 15.6 and 20.3, things start to shift so that you've got the growth rates are positive, but these rates decrease. You're kind of like at their red line. They're not going to be increasing with warming temperatures. The metabolism is increased dramatically. The pathogens are working better at those higher temperatures, and competition with other species, non-native fish are doing better as the temperature gets warmer. So is it a lethal temperature? No, but is it working into the fish's best interest? Definitely not. And if you treat these fish as though they're a sick patient, which is what the population dynamics are telling us, you don't want to put them in suboptimal conditions. You want them in the best conditions that you can create. Well, fortunately, spring water coming out of the ground is in the optimal range. The springs that are in the upper watershed are like 13 degrees is where they come out of the ground. And it doesn't take any magic. All you just do is leave it alone. The part of the problem is that there's a huge demand for water within the watershed. This red line is an average flow measured at the mouth of the river during the irrigation season. So going back up to this point here in irrigation season starts on the 1st of April. So prior to that, we're looking at, unimpaired flows. If you took out all the storage that's going into reservoirs and ponds and groundwater pumping, you're looking at about 300 cubic feet per second. Irrigation season starts and you're going to drop down to, like Andy pointed out, well, less than 5 cubic feet per second, but these are average values. So, but you can see there's a large bite taken out of the unimpaired hydrograph, to the point that you actually, in June, you're looking at some of the highest flows because that's when the springs would normally be contributing. Springs in the upper watershed scattered around. This is Lake Shastina. This is Juvenile Dam. So there's other springs in this, but these are the ones that we studied. The Big Springs Creek, Clear Springs on the Shasta main stem, Kettle Springs, and Bridgefield Springs. Just as an overview of the watershed. So you're looking at the canyon reach where you find fish spawning, but they're typically not being able to over summer there because the water gets so warm down here. But up in this area up in here is where we started finding fish rearing. So this is just to step through what a typical cohort has to contend with. They're coming in November, December to spawn, and they're spawning in these areas. So the red ovals are where we find spawning. And the way we know that is that we radio tag fish starting in 2006, and we flew the watershed and we found out where the fish were actually, depositing eggs. Spawning juveniles start to pop out of the gravel in April and May of any year, but this was for brood year 2010. Then they start to distribute in the watershed. They come out of the gravel, and they're going to be found in these regions below where spawning took place. And this is early spring when the water temperatures are still favorable. They're still optimal because it's cold outside. Then once we get into May and June, this is the irrigation season is kicked in, and flows are dropping, and you're starting to get a lot more sunlight. So the river starts to warm quickly. Plus, you get a lot more tailwater coming through. So the fish now are restricted to rearing directly downstream of springs. So Clear Springs, Kettle Springs here. These springs are all impacted from egg use and Big Springs. So their habitat, is really limited now. The main stem Shasta River becomes pretty important because you've got spring inflow here, sub-channel, in actual they're very small springs, but they're enough for the fish to hang on to. Then in the fall, once the temperature restrictions back off, the fish redistribute and they you can find them rearing all throughout the watershed. In fact, you probably could find them downstream. This was done from tagging studies where we actually had pit tag antennas that allowed us to detect where the fish were. So they're spread out. Come springtime, when the fish are ready to leave, this is what they've got to leave. They got to get through. Winter rearing looks like very similar to what we just talked about. And then following the spring immigration as the smolts leave, they've got to make the gauntlet. So we in 2007, it was in 2009 study, we looked at how did the fish do leaving this one spring. So we had tagged individuals all throughout this reach. We had a pit tag antenna right here, and we had pit tag antennas all the way on down this yellow line to the mouth of the river. And what we found was that that's Clear Springs. That's one of the springs that feeds this rearing habitat. That's what it looks like, from the surface. These are small. This is like a 5 second foot spring, but underwater it looks like this. So this is those fish from brood year 2007. They're large, extremely large compared to other coho that are rearing throughout the Klamath because they're feeding really well, and their water is in this optimal range. But this is what it looked like when they tried to leave that year due to irrigation. Flows were like less than a couple second feet of water. Beaver dams were constructed, beaver dams are good things, but not when you don't have high flows to open them up during the spring immigration. So fish had to migrate, literally through this shallow water down through here. And all the, birds, they all know about this, and everybody's ready for them when they come through. This is just assume that this is the upper end of the watershed where you've got 100% of your tagged individuals. This is the downstream end of the watershed. So basically you had 56% mortality between getting from here and here. And that emigration takes place only in about a 2-week period. So this is a model that Chris Adams, who was working for us at the time, went on to study this over at Humboldt State, got his master's, and then went to Michigan State and got his PhD doing this work with pit tag antennas. So what you end up with is 4%, roughly 40% of the fish survive to make it through this gauntlet of low flow and high temperature. So you've got these fish that have been rearing for 18 months and you lose them all in a space of a couple of weeks because you don't have enough temperature or enough water and temperature for them to survive. So this is only from one location in the watershed. So Chris went over to Humboldt State and he did additional studies looking at the distribution and survival from other ports within the watershed. And the problems exist throughout. But the findings from this work was that the distribution of rearing juvenile coho changes seasonally. So they're not going to stay on one property in one place. They're going to be moving throughout the watershed. Regardless of where they come out of the gravel, they're still going to be widely distributed. So you can't really, pen them in or have them stay in one location. They need to move around. And typically they're going to be looking for the cold water. When smolt emigration is underway, that's when the irrigation season starts. And lastly, you've got to have a pathway throughout the entire range of the watershed where the fish are rearing to get to the mouth for them to survive. How am I doing on time? Are we looking at, are we getting close? Who's are you a timekeeper there, Liz?
Yeah, you've got a couple more minutes.
Okay, so anyways, the monitoring needs are, we've got to look at surveys to find out where these fish are located. We need real-time water temperature monitoring. We need pit tagging to estimate their survival. And we need location and quantity of water diversions and return flow to the river. I mean, this won't just happen automatically. Historically, you had springs in the Shasta River, you had wetlands. So this was on the main stem Shasta River below Juvenile Dam now. There was a large wetland. This is from a 1895 topo map. And here's Parks Creek, where there used to be springs as well. All this stuff has been developed for agriculture and the springs have been captured. We pit tagged coho at the mouth. That's an antenna coming out of the mouth of one of those adults. And then we flew the watershed and we found where the fish were rearing and where they're spawning. And this is what it looks like. It's not, it doesn't look like your typical coho habitat. What brings them back here, that's a red that's in that circle. What brings them back to this location are these springs. So there's a large spring complex right here, and this feeds Parks Creek, and there's more springs back in here. All this stuff is been impacted by ag. These are all diversions on the watershed that really impact the flow. And it's not just a one season impact. Like this is what it looks like in the fall of the year after the typical irrigation. Water's still being diverted for livestock. So this is put a push-up dam in there to drive the water and push it down an irrigation canal to water these cattle that are at the end of the ditch. All this stuff is still going on in spite of all the commotion and attention to things that have changed. These fall diversions are still reducing the flow. This is a piece of a ranch called Shasta Springs Ranch that has a spring that we just talked about. This water is diverted probably 4 different times by the time it reaches the Shasta River. This is Juvenile Dam over here. This is the Parks Creek watershed. And these are the series of impoundments. Everything that's green is being flood irrigated. So that's water that's been taken out of the channel and is being used to grow alfalfa or just forage for cattle. So this is Parks Creek on the left. This is a diversion of Bridgefield Springs, and this whole thing used to be the wetland that we showed on that old map. This is we did a survey in 1995 and found that Chinook were spawning in here. It used to be accessible to anadromous fish. That's a picture of me standing by the spring in 1995. This is what the spring looks like when it was stored, and then it's dumped all at once across this field, and it results in a flood irrigation practice like this. They'll pound it up with diversion, soil, piles of soil and piles of irrigation tarp to hold the water on the field, and has the effect of warming the water and loading it with nutrients. And then they'll bring in livestock like a feedlot, and all this stuff is oozing this direction. It hits this levee, which is a man-made structure, and it runs it into this channelized version of Parks Creek. And you end up with a stagnant slough of effluent before it hits Parks Creek. And all this is being still permitted. You're taking 13-degree water and it's over 22 degrees by the time it reaches Parks Creek, which is a tributary to the Shasta River. 60% of the water is being used by crop evapotranspiration. 40% of it is not being used. This is from a study by the Grant Davis, an engineering group that was hired to look at the efficiency. The impacts of this operation on Parks Creek was it blocks spawning access, it elevates water temperatures, it limits over summer rearing habitat. I don't know amount of time, but Montague Water Conservation District is having many of the same impacts. Their one real easy low-hanging fruit is that they're dumping Twinnell water and they're conveying it downstream to users. And so there's like habitat that's in the main stem channel that's being inundated with, 25, 26 degree, nutrient loaded water temperature from the reservoir. That water needs to be put into a pipe. It needs to be conveyed someplace. There's barriers to cold water on Big Springs Creek. These impoundments, just real quick, this is an impoundment of the springs that used to flow naturally into this Big Springs Creek. Instead, what happens is this is Big Springs Creek down here at number 1. This is about a little less than 2-mile course of stream. But because we have these impoundments, these man-made impoundments that are being used for pumping, what you end up with is the water temperature starts at 13 degrees at the upper end here. And by the time it gets to number 7, it's already up to 20 degrees, 19 degrees. So in a real short space of time, you've elevated the water temperature so it's no longer optimal for coho. I had in 1992, we had a fish kill on the Shasta River, and it was because the river went from 125 CFS to 25 CFS overnight, and the water temperatures just spiked and the DO went down. And it caught it. There were a lot of dead fish, and that's pretty sensational when it happens like that. And so the Chronicle did a story on it. And I remember I got a phone call from a guy in San Francisco saying that he had refrigeration units. And he goes, I can cool that water if I bring up my portable refrigeration units. And, and of course that's not the solution to it. But, I think about that all the time because the nature has given us 13-degree water. All we got to do is just open it up and keep it accessible for the fish. You don't have to bring in refrigeration units from San Francisco. We just have to provide passage for the fish to get to this water. But that seems to be the hard part. So increased smolt production requires access to the juvenile spawning habitat, suitable conditions during egg incubation, access for the age 0 fish to get to the cold water habitat, and then passage for the smolts to get out of the system. And then coordination, really importantly, between the irrigators and resource managers. The safe harbor agreements, they don't do that. They don't provide for sufficient measures to increase the smolt production, and they don't have any monitoring in place. There, way over time. Sorry about that.
Well, thanks, Bill. That was an amazing amount of information that you were able to cram into that sort of speed overview of all the issues that these fish face in the Shasta, and it's really unfortunate. I want to open up questions, but I want to start with a question actually to Andy. We have an action alert open right now for the Shasta. Can you talk a little bit about that, Andy, what you're hoping people will help out with?
Yeah, for sure. So one of the really kind of exciting things for us that's happened this essentially spring, the water levels got super low, and we have been engaging, I guess is the politically correct term, everybody we can. Yelling and screaming might be another way to describe it. But Fish and Wildlife has recommended to the California Water Board that they issue what's called a curtailment order. And so actually today at 3, there's a hearing, and we're trying to encourage people to attend. But there's also through the action alert a way to essentially send a letter commenting on that. What we're trying to do is encourage the water board to follow through with the order that Fish and Wildlife is seeking, which would be 50 cubic feet per second at the mouth of the Shasta River throughout the summer season. It's not the sole remedy, but it goes a long way toward helping out the fish. The fall Chinook run is going to show up soon. It gives them a lot more access to the river. It would just go so far. We included in that letter a little something about temperature. We're concerned because The temperature impacts have not been incorporated into the flow order. So we want people to, you know, comment and say, you know, temperature is important too. You need to consider that. But what we're really focused on right now, and the timing of this lunch and learn was great because this hearings today, the order would be coming fairly soon, and it would be miraculous for the Shasta to just get that 50 cubes through the summer period, and much better flow kind of plan for the river throughout the season. And that'd give us a little breathing space to then work on something more permanent. But that's our immediate focus, is trying to really motivate the water board to make the order that Fish and Wildlife has recommended.
So I just, for all of you attending, I posted a link to that action alert that we have on the NFS website into the chat for this meeting. And then it looks like Conrad also posted another link. Conrad, do you want to really quickly mention what that link is for there?
Sure, yeah, that's the direct link to the water board notice about their proposed regulation. So today, starting at 3, I would encourage all of you to at least listen, if not chime in on that Zoom chat. So if you click that water board link from 3 to 5, they'll be discussing it. They'll probably hear from a lot of cowboys who don't want it and a lot of fish lovers who do. And then the written comments are due Friday. And one more thing, just briefly, reading the regulations, there are a lot of off-ramps where there could be cooperative solutions. And invariably that means alternatives to water for fish, which the agencies love, the farmers love, and a lot of big green enviro orgs love. And bottom line, the fish need a certain quantity and a certain temperature. We need to follow the science. Now is the time, and close all these off-ramps.
Thank you so much for sharing that. Okay, so there was a question actually from someone who registered for this webinar online. So the question was, California has long talked about raising Shasta Dam. What is the likelihood of that given the impacts of global warming and the need to store more water?
It's kind of I mean, it's off topic because, and I think it's probably just a basic misunderstanding, but Shasta Dam, Keswick Dam is the one that's being, you know, is that refers to, and that dams essentially the Sacramento, the Pitt, the McCloud, a couple other creeks, and forms Lake Shasta, and that then flows down the Sacramento River. I, you know, couldn't weigh in on that other than I know it would inundate a lot of the McCloud River, which is a favorite trout fishery of many people. But it does strike me that, you know, maybe we need to think beyond raising dams and think about using water more wisely. I can kind of segue into an issue on the Shasta River, which is Bill referred to Juvenile Dam, and that forms Lake Shastina. So one of the kind of tragedies of the Shasta River is Lake Shastina impounds, basically holds back all of the snow melt from the surrounding mountains and diverts it into a ditch. Very little goes down the river. And the only thing that really goes down the river is, as Bill referred to, there's a town called Montague, and they use the river as a conduit for their domestic water supply. But the problem is that that water that comes out of Lake Shastina is impaired due to temperature. It's really poor quality water. And so using the river as a conduit rather than putting in a pipe to get the water to that town doesn't help the fish. There's this concept that, oh, more water in the ditch is a good thing, but it's got to be the right kind of water. You know, one of the things we want to see eventually is more water, kind of more mirroring a spring snowmelt hydrograph coming out of Dwinelle into the river so that there could be more gravel transport. One of the big problems the river has is the sediment from basically cow poop that lays in the riverbed and doesn't get washed out, and that impacts dissolved oxygen levels significantly, which then has an impact on temperature. So the dam is a big problem on the Shasta as well, but it's so awesome that it's got these springs and it could be pretty resilient even in spite of that dam if the springs were freed up.
Thanks. So Mary had a question. Wasn't Cal Trout promoting their involvement with the local ranch owners as one of their successes? And maybe can you give a little information about that if you happen to know?
Yeah, I can for sure. So when I met with Bill and Dave, I'm actually, I was a guide here, and I guided on the Klamath. I'm familiar with Cal Trout, done some trips, know some of the principles with Cal Trout. And so one of the first questions I had for Bill and Dave was, well, what about Cal Trout? They're doing all this great work up on Big Springs. And the answer I got, to sum it up, is they're collaborating with people who have all the power. They have the water rights. They have a piece of paper that says you can take all this water. And so when you go into a collaboration with somebody where you have zero power and they have it all, you're just basically holding out your hand and hoping they're going to drop something in it. And we've definitely, interact with Cal Trout, and we're trying to understand their approach, but our approach is that we need to have more power on our side in order to get the landowners to really engage in a meaningful, voluntary kind of sacrifice of what they've had for so long. And I can just tell you, like, for example, there's a 2003 Scott Shasta Coho recovery plan. One of the, entities from the environmental side was Cal Trout, and that was 2003, and the fish numbers have done nothing but drop since then. Not that it's Cal Trout's fault, but these collaborative efforts, the latest one is called the Safe Harbor Program. It was a program that was negotiated with the involvement of Cal Trout and the Nature Conservancy. All the parties in the negotiation were essentially shielded by confidentiality agreements. So we don't know what occurred in the negotiation, but we've looked deeply into the Safe Harbor Program, and we are not satisfied that it's going to really do what the watershed needs. It only includes a fraction of the landowners within the watershed, and it's all about voluntary measures. They're, kind of as, I guess, an analogy or something, there's this, the Shasta River is impaired under the Clean Water Act. Dissolved oxygen and temperature are the impairments. There's been for 2 decades what's called an action plan, kind of overseen by the Water Board, trying to remove those impairments to get the temperature down and the dissolved oxygen up. And they haven't really succeeded. You can't look at the fish numbers and say they've succeeded, and you can't look at the, they want to show you averages, like on average the water temperature has gone up. But what Bill has hammered home in my brain is fish don't live on the averages. One bad day is all it takes. And so while, collaboration sounds great, unless you're collaborating from a position of power relative to who you're dealing with, it really hasn't worked on the Shasta. And our goal is to take some of that power back, using techniques that maybe some of the other environmental organizations have not been willing to go to. I mean, we're not like, I guess, sue happy, but if it comes to targeted litigation, that's one way that we want to try to kind of shift the balance a little bit. So, Cal Trout back in the day when Mono Lake was imperiled was a different organization than they are today, in my opinion. Much more aggressive.
So I want to respect everyone's time. So just one more question, and then we'll call it for the day. But has the Western Rivers Conservancy been involved in trying to protect the Shasta River watershed?
So I pitched to Western Rivers that they purchase the Shasta Springs Ranch. The pitch was met with, well, we are interested in that because it certainly looks like prime water that would benefit the river if it was conserved, but we need funding partners. And it's not a cheap purchase. I tried to get Patagonia to become a funding partner. So far I've been shot down, but that, I'm okay with hearing no. I'm going to keep asking. They did seem interested. It would solve so many problems on the Shasta River if we could get somebody in on that property.
Okay, and then, yeah, Conrad points out that Western Rivers actually has purchased some land with water rights, but chose not to dedicate the water to the Scott River. I guess is where that property was. So, so I think with that, we're going to end it for the day. Thank you so much for everyone for attending. Thanks to Andy and Bill for a great amount of knowledge that you shared today. And like I mentioned before, please take that action. You know, go click on that action alert. It's an easy thing to do. You just have to put your name on it and send it off. And if you're interested in joining our Hot Home Waters team, please contact me, and I'd love to have your input on that as well. So
Join us at 3 o'clock, Waterboard, historic day.
right.
Yep.
Thank you. Thanks, Conrad, for that. Thanks everyone for attending. And until next time, we'll hopefully see you soon.
Thanks so much, everybody. Hopefully I'll see you out there one day, Mary.
I hope so.
Everybody. That was really, really interesting. And I'm really like stoked now for 3 o'clock. So
Right on.
Yeah, we need to make sure that they're including temperature in the mix. It's not just enough. They told me that, well, that water volume was a surrogate for temperature, and it's not true. You know, that you need that cold water that's coming out of the ground, and it's not all water is valuable. So if we can encourage them to consider that, that'd be great.
All right. Well, thanks, everybody. Thanks for showing up.
All right, thank
Great
you.
presentation. Thank you.
Okay,
Incredible. You and